Hi, we are Group 10 and we are creating an AI for the snake game. So, a snake game, uh, in our implementation, we start with we have an arena of 10 by 10. The initial state has a fruit and a snake randomly spawn on the arena, and the initial length of the snake is 3. So our AI will control the snake. When the snake eats a fruit, it will get 1 block longer, and the agent will get a positive reward, a +1 reward. However, if the snake hits the wall, it hits itself, which is the terminal state, the game will end and the agent will get -1 reward. The purpose of our AI is to score to try to get as much reward as possible and avoid this terminal state. Our project uses two algorithms at the same time, PPO and A2C. We try to see which one is more performing better and which one is easier to train. A2C is an actor-critic method. It has two networks at the same time. The actor chooses the actions, and the critic try to update the policy that the actor uses. Uh, for PPO, it is almost the same as A2C, but it is more stable by limiting how much the critic can change the policy in each update using a clipping function. And here we can compare the performance between PPO and A2C. The graph is the average reward throughout 10 million steps of training. We can see that PPO, which is the gray graph, the gray line, performs better at first, but then it gets performs less the longer it goes. In contrast to that, A2C performs worse at first, but then it gets better over the time. Another thing we would like to point out is that during training, A2C has more fluctuating reward than PPO, probably due to PPO having a clipping function on policy update. Here we can see that in the first 1 million steps, the snakes are actually not doing anything. It takes a long time before it can eat the fruit. Uh, this applies to both PPO and A2C algorithm. And here we can see that after 10 million time steps, the snakes are eating much faster and it generally knows where the fruit is. Unfortunately, we still haven't met our baseline goal, which is like 50 points out of 100 max, and our current average score is like 7. I think the baseline is a bit too ambitious, but well, even if we still haven't met the baseline goal, we will still try to add more challenges to see how it would affect the learning process of both algorithms. A challenge that we have in mind is adding obstacles into the arena so that the snake have to try to learn to navigate around those obstacles. And another challenge that we think about is adding like having an extra fruit on the arena aside from the main one, but the extra fruit will have a time that will disappear after a certain amount of time, and the snake will have to learn to optimize whether it should go for the time fruit or it should do something else.